Hey, what up, guys? This is Nick DeQuan. Today we have another post for today's highest mathematical edge pick. I haven't been able to post for about the past 2 days. Was on a little bit of a vacation, but last post I think was the 29th. We had the Miami Marlins as our highest edge pick. They started out really slow against the Mets to give up 4 runs in the first inning, and then they really took control all of the game, but they were trying to constantly get out of a hole. They lost by 1 run. I've been pretty unlucky when betting on the Marlins this year. They either just underperform or they're performing just as they need to and they're dominating in hits, but they just can't score runs. But saying that, we're coming off of a largely profitable week, over 8 units profit. Now we're in this new week. I've reduced my Kelly criterion from a 1/6 of a Kelly to a 5.5 Kelly, trying to essentially benefit from the fact that my model's variance is reducing with all this large data accumulation, and therefore get on the train for more profit as we reduce this Kelly throughout this, 60% or majority rest of the season, or maybe a little bit less is left. We're nearing the halfway point eventually. So that's kind of where I'm at right now, but we can get right into this pick today. I'll break down the math, usual regiment, go over the interior models, talk about the calibration, and then we'll go over the ensemble output, get into the 2 layers of calibration there, talk about the market regions, and then just kind of summarize the edge assessment. So saying that, today we have the Kansas City Royals on the money line. I got them at plus 162. So again, still betting on DraftKings, but I really do want to start getting into line shopping, especially getting on markets like Novig, which right now is like the mecca of expected value betting. So I definitely want to start doing that because there's been multiple instances where I take a large underdog and I get them on DraftKings at plus 150 or plus 160, but then I Novig or another book, they're like plus 180. And I'm like, wow, okay. So, missing out on like legitimately much higher ROI given my probabilities being accurate. So my model has the Royals at a 46.53% probability. Again, at those plus 162 odds on DraftKings. That right there shows you that mathematically, my model is favoring the Reds slightly. A 46.5 through the complement of that being, in that kind of indifferent range when we're talking about probabilities, at least in short term, singular game outcome events. So yes, mathematically, my model is favoring the Reds a little bit here, but pricing wise, my model views the Reds as being significantly overvalued. They're minus 198 on DraftKings, but on other books, they're, man. So, dude, every time I film these videos, I just start yawning. Like, I get done with my work, do my, I wake up, I do my cardio, I do my work, I look at the market, and I'm like, okay, I feel great. And I film the video, and I just start yawning. It's like I'm getting sabotaged or something. I just start yawning. So I do apologize. But getting back to that, yeah. So mathematically, some slight favorite in the Reds, but relative to the Reds pricing, massive pricing advantage on the Reds. On the Royals. My model views the Reds as being significantly overvalued, and likewise, the Royals as being significantly undervalued. So given that probability and at their odds, the Royals, according to my probability and the current odds I'm betting at, have a 21.91% expected value. We're going to be risking 2.25%, or for me, 2.25 units, with a potential profit of 3.64 units. So we can just kind of go through the math now that we've started the video off with that, kind of giving you guys the pick right there. And yeah, so again, my ensemble model has 9 interior models. Each model spits out an initial prediction. That calibrated probability, the probability I'll be saying, is the empirical win rate of that initial prediction. How much these win rates or these calibrated probabilities influence that total ensemble model probability output is dependent upon how reliable they are, which comes down to how large of sample size we're dealing with. So I want to get into that real quick before I just kind of scan through these 9 models and talk about that initial ensemble output. So saying that, the first model has the Reds at a 64.79% probability. The second model had the Reds at a 41.67%. The third model had the Reds at a 61.76. Fourth model, Reds 66.67. Fifth model, Reds 50%. So now going over to model 6 here. second. Here we go. Model 6, Reds 53.33. Model 7, Reds 13.33%. That's probably the most diabolical contrarian signal I've seen so far on a large favorite. So again, what this means is their initial prediction, I'll just say, right, their initial prediction had the Reds at a 66%. That's Model 7. When Model 7 says, okay, hey, this team has a 66% probability, the actual winning rate of that is 13.33%. Sample size isn't massive though, so it's still going to influence the probability, but the sample size is not massive there. So that's why it's so important to anchor the weighting of how these influence the total probability based on the reliability of the said, outcomes or probabilities relative to their sample size. Model 8, Reds 51.52, and then Model 9, lastly, Reds at a 66.67. So we can see almost all of the models are clearly favoring the Reds, but what matters, again, is the model, just because they're favoring the Reds, we still have to think about the pricing of the Reds. So are these models favoring the Reds enough to where they'll give you, a mathematical advantage that is larger than their current pricing being offered by Vegas, or will it be less? And as I just said in the beginning of the video, it is significantly less. So the initial ensemble output after those 9 models are ran is the Reds at a 54.75% probability. So now we're going to use second layer calibration, which is using empirical Bayes. So it's going to take into account that initial output, which was a 54.75, I believe, yeah. And then what actually happens in the real world based on the results of said probability. As sample size increases, just as really all methods of calibration, but empirical Bayes as well, as that sample size increases, empirical Bayes starts to rely more on those real world outcomes and rely less on that kind of like abstract model output that we don't really know how it correlates with the real world results. So getting into that, when my ensemble model output produces 54% probabilities, it's only been hitting 47% of the time this MLB season. So empirical Bayes is going to drop the raise in this second layer now to a 51.92% probability. So again, at minus 198 or across a lot of books over minus 200. Very slight mathematical advantage, but extremely overvalued pricing wise. So now we go into the market region. The Reds, the market region they fall into today, currently has a 56.41% win rate. So that is advantageous mathematically relative to the market. But again, to the Reds pricing, that is disadvantageous. So really the entire model, those 9 interior models, for the most part, the second layer calibration and third layer calibration say, okay, yeah, the Reds are mathematically favored, which really anyone can come to that conclusion considering what their odds are, the pitching advantage they have today, etc. But relative to their pricing, they're at a big disadvantage here. So we apply that third layer calibration. And we get that finalized probability for the Reds, which gives the Reds a 53.47% probability, bringing us full circle, back to what their odds were. And we can see that they're at a significant disadvantage. So the play here is definitely the Kansas City Royals money line, risking 2.25% for potential profit of 3.64 units. So that is the pick today. Thank you for watching.